Hello everybody, welcome to all of you, and thank you for joining us in this new Shining 3D webinar. This is Riccardo, and today, together with my colleagues Filippo, Simone and Rita, we will have a look into the digital workflow provided by the integration between EXOPLAN and the Shining 3D printing system with the DLP printer AccuFab D1. Let's have a look at today's agenda. Before stepping into the workflow, we will have a quick overview on the most important legal and commercial aspects related to EXOPLAN as a medical device, which is really important to know when we approach this kind of software. After that, we will spend a few words about the management of the EXOPLAN basic license and the possibility to add the module for surgical guides, describing what are the features included in the implant planning and what is available only with the additional module. After that, we will finally step into the practical demonstration of the software, editing an implant planning and the design of the surgical guide. And then we will export our file into our DLP printer software for the final production of the surgical guide itself. As always, at the end of the demonstration, we will have a Q&A session and we will be fully available to answer your questions. As mentioned, let's start by highlighting the most important aspects that we need to know about EXOPLAN as a medical device. First of all, one of the most important features of a medical device software is that the developer, in this case EXOCAD company, has to be in condition to take back the product every time a malfunction or a bug comes up, and fix the problem before releasing the software again. In order to do so, all licenses must be always updated at the latest version available. That's why EXOPLAN is available only as a flex license, so no permanent license is available for this software. Another important aspect to highlight is that all EXOPLAN users have to be trained by a certified EXOPLAN trainer in order to be fully aware of how to use this medical device in the most proper way. Shining 3D Dental Team is of course a certified dental trainer, so all our partners and customers will always be able to rely on our expertise for this mandatory step, and for following support on the software, of course. Last but not the least, when we say that EXOPLAN is a medical device, we mean that projects and restoration edited with the software are actual treatment plannings which have to be formally approved only by the dentist responsible for the treatment itself. In case you need any clarification on any of these aspects, we can for sure clarify any doubts during the Q&A sessions at the end of the webinar. Talking about what we can actually do with this software, it is important to clarify that, as it happens with EXOCAD Dental CAD, even for EXOPLAN, we have a basic standard license and then the possibility to add more function for additional tools. More in details, with our standard license, we can complete the workflow for the implant planning based on the match between the STL files and the DICOM CPCT files. And then on the basis of this information, we can define the implant positioning having the most clear and complete information about the anatomy of the patient. If we want to move forward and go ahead with the design of the surgical guide, we can add the Guide Creator module. Thanks to all functions and tools included in this add-on module, we will have the chance to customize the surgical guide considering the specific situation of the patient and everything we need to perform the most efficient insertion of the implants. Then, at the end of the workflow, we will be able to export the STL file of the surgical guide we have designed and send it to our 3D printer for the final production. We can now start our demonstration through the implant planning and the design of the surgical guide. If you have any questions about the process, please feel free to leave your comments and we will get back to you in real time and also during the Q&A sessions. Here we go. Let's start with the job definition of our implant planning on upper jaw. It's going to be a planning for 2 screw-retained implants on 23 and 26. And then in a second step, there will be the design of a surgical guide. As you can see, the user interface of EXOPLAN is pretty much the same of dental CAD ones, so I assume that most of you is already familiar with it. Once we have selected the teeth for our restoration, the adjacent teeth and the antagonist jaw, we can select implant planning on the right, and finally start our project. First of all, when we launch the implant planning, we have to select and import the meshes that will be the basis of our project. Following the instructions suggested by the software, we will have to import at first the STL file of master jaw, then after that the antagonist, as suggested here, and in a third step, after the import of the STL, EXOPLAN allows us to select the folder of the DICOM files containing all the CT data, and then eventually to import them. Now, as soon as all data will be loaded, all the meshes that we will need for the project will be visible all together on our screen. Here we go. And now, as you can see with the surface threshold slider, we can regulate the transparency in order to highlight the isosurface we want to view. We can click Next, and in this new phase we have to go through 3 different steps. First of all, we have to regulate the slider of the transparency in order to have the soft tissue completely visible, as you can see now, and then confirm this view by clicking the first icon in the box on the left to confirm and close the first step. As a second step, we have to regulate the same slider to hide the soft tissue, we no longer need it, and proceed with the selection of the bone. Once we have a clear view of it, we can confirm again with the second icon in the box. Lastly, we will move the slider once again to highlight only the enamel. Please consider that this selection has to be done with a particular accuracy, because on this isosurface there will be the alignment of the master jaw and the alignment of the antagonist. So it's particularly important to give the software the most precise information for this step. So trying to be as accurate as possible, also by using the icons that you see here, we have to define the best selection of the enamel, and once we're done, confirm once again. The next step is the definition of the panoramic curve, or in other words, the selection of the area where the restoration will take place, both from maxillary and mandibular points of view. There are 2 main tools we can use in this phase. At first, by using the scroll of the mouse, we can drag up or down the cutting surface. And please note the simultaneous movements in the 2 windows on the screen to have a more precise perception of the position of the cutting surface from 2 different points of view. Then we can of course drag the lines here to better define the panoramic curve of the restoration area. Of course, we have to play around a little bit in order to find the best combination between these 2 aspects. But as you can see, the tools are really intuitive and user-friendly. According to the specific case we have to deal with, we will have to define the curve in order to follow the profile of the jaw, as you can see. Last but not the least, for this phase, as you can see in the box, we also have the function to flip the perspective in the box. And once we're done, we can go to the next step. In this new window, we can now proceed with the matching between the STL file of the master jaw and the CT surface. We are going to select 3 different spots in the same positions, both on the isosurface on the left and on the STL file on the right. Please consider that the larger is the distance among the 3 points, the more accurate will be the matching. So, if possible, please try to choose the 3 points along the full arch, as we are doing now in this demonstration. Once we have our 3 spots in the same position on both files, we can launch the matching by clicking the icon Start Best Fit Alignment to let EXOPLAN proceed with the calculation for the matching. At the end of this process, our files will be finally aligned, and we will have the chance to choose whether move on or try a second method for the matching, according to the result we will have obtained. Calculation is now in process. May take a while, but here we go. Thanks to the color map we can see now, we can check the quality of the matching we have obtained with this first method. In blue, the discrepancy between the two files is 0, while in red we have the maximum distance. As we'll understand, it is absolutely important to have here a perfect quality of the matching and a high level of accuracy, as this matching is going to be, of course, the basis of our implant planning and of the design of the surgical guide. There is also a second option to align the two files in case we are not satisfied about the quality of the matching with the first method. In this case, by using the lasso tool, we can clean the isosurface on the left by removing parts of the file that will not be considered for the alignment, as you're seeing now. So we can select and delete all the noise around the teeth, as well as the visible portion of the bone. Once again, it's better to be as accurate as possible and delete as much useless data as possible in order to make then the calculation easier for the software in view of a perfect alignment between the two files. Once we finish to remove all the useless parts of the CT file, we can select the brush tool to highlight on the STL file the parts of the file that we want to use for the matching with the isosurface. Of course, we have to select just the teeth, not selecting the gum, as it is not a common part between the two files. And once the full arch has been selected both from vestibular and palatal side, as we are going to do now, we can proceed with the matching once again. As it happened before with the first method for the alignment, we have to wait a few seconds for the software to complete the calculation. Once calculation is done, here we have again the color map that shows us once again a good quality of the matching, so we can confirm and go ahead to the next step. Now, EXOPLAN is asking us what type of implant project we would like to edit. We are selecting the option screw retained implant on both the elements, and we are going then to the placement of the teeth by selecting the mesiodistal areas to properly place both the elements, both the teeth. Here we find the same tools we are used to find in EXOCAD Dental CAD for placing teeth. So we can of course move them, rotate and scale them according to the specific needs and in order to best adapt elements to the context for the patient himself. In the next step, we have to define the density of the bone using the threshold in the box on the left. The blue part is of course the bone of the patient, and in red all around we have the soft tissue. Let me please stress out that it is extremely important here to be as accurate as possible in defining the density of the bones, as in the following phase during the implant positioning where we are now. This information will be essential to understand whether the implant will be in contact with the bone or not. In this phase of implant positioning, on the right side of the screen, we can also rely on the information given by the CT files from different views. Once again, we can notice the simultaneous movements of the implant both on the STL file and in the windows on the right, where we can also enable and disable other views in order to have the most accurate and precise idea of the real position of the implant. Among all functions and tools we can use in this phase, it is really useful for sure to enable the color map of the implant itself, where the red and blue colors appearing on the surface of the implants will let us understand if the implant will be correctly screw retained into the bone. Blue and red are of course the same colors defined in the previous phase, and the information we can find here depends on the setting of the density of the bone that we have selected in the previous phase with the threshold slider. We can of course change the position and the inclination of the implant in order to find the best fitting, always considering all views at our disposal. So both on the STL and on the CT files, in order to have the maximum precision about the position of the implant, we can enable the view with bone density in the window on the right side, as you have just seen now. Last but not the least, in the box on the left, we can choose the model of the implant and select the diameter and length. Let's select a random brand among all the ones available in EXOPLAN, and random measurements as well. By changing the implant model, EXOPLAN shows in real time the change of the standard length and diameters, as you are going to see in a few seconds. According to the specific model and measurements of the implant we are using, we will always have the chance to correct the position and the inclination in order to find the best fitting. As previously said, this planning has to be done and approved by a dentist. Please forgive us if in this demonstration we are not sufficiently accurate from the medical point of view. On the right side of the screen, in the window on the bottom right, we can see a preview of the screw hole along the bone as a reference for the placement of the tooth. At this stage, it is important to look for the best implant positioning in consideration of three main elements, which are of course bone density, as we mentioned before, position of the implant itself, and the screw hole. Speaking of the screw hole, in order to find the best position for it, we always have the reference of the crown in transparency and the axis of insertion of the implant, as you have seen on the screen right now. An important aspect that we would like to highlight at this stage is that EXOPLAN selects a different workflow according to the jaw where we are defining our restoration. Indeed, if we were editing a project on the lower arch, EXOPLAN would define a dedicated workflow, including a specific step to protect the mandibular nerve, which is of course a crucial step for a safe planning and a successful treatment. We can now edit the final modifications at our implant planning and have a last check at it, looking at all the visible elements on the screen. And then, after that, we can finally move to the next step. Let's focus now on the placement of the sleeves. Looking at the box on the left, we can see that according to the model of implant and its features that we had chosen back in the workflow, we can find here the corresponding data and features for the definition of the sleeves. Also, by moving the pointer of the mouse on the sleeves themselves, we can see more information about them. After the definition of the sleeves and before moving to the next step, we must pass through the process of approval of the plan and the creation of the PDF report, which will include all the details of our implant planning and all the parameters that we have set so far for the restoration. Okay, we see now the icon Show Report in the box on the left, so we can now have a look at the content of this report. As we can see, everything defined during the workflow so far is included in this extremely detailed report. Starting from the anagrammatic of the patient, then we can see the radiographic image with implants and sleeves already placed in the position defined during the project. We can see it here. We have an implant overview and related information about the model we have chosen, measurements, and so on. And last but not the least, we have a series of detailed screens taken from the workflow that we have followed up to now. Here we see it. Okay, what we're going to define in the following steps is the design of the surgical guide, which, as mentioned at the beginning of the webinar, is available only as an add-on module, so it's not included in the basic version of the software. At first, let's focus now on the design of the sleeves. Of course, we cannot modify the internal part that has been already defined and approved in the previous steps, but we can focus on modifying all parameters related to the structure of their external part, as we can see in the box on the left with the sliders regarding minimum thickness, additional rounding, height, and radial offset. We can, of course, play around with the sliders in order to achieve the best result in our design. And once we have defined all parameters and achieved a satisfactory result in our design, we can move on in order to define the insertion direction of the surgical guide. When we land in this page, EXOPLAN is already suggesting the ideal insertion direction, but we always have the chance to rotate the model and set the insertion direction from view that we consider the most correct by clicking on the icon on the left. When we click it, we can see the purple halos around the teeth showing the undercuts we would have by adopting that specific insertion direction. And again, we can choose the direction we prefer, and after approving it, we can finally focus on the design of the surgical guide. As we can see, the definition of the profile of the surgical guide is pretty much the same of the bite module in EXOCAD Dental CAD. So we just have to select the spots around the teeth, including, of course, into this selection the sleeves that we have defined in the previous steps. It is dentist's decision to define the portion of the arch included in the surgical guide. It is not mandatory to cover the full arch, but please consider that the more teeth are covered by the guide, the easier will be for the software to reach the maximum precision for the definition of the guide itself. As always, in the box on the left, we can set and change our parameters for the design. In this case, we can modify thickness and smoothing of the guide's surface. At the same time, we modify a parameter and we would like to have a preview of this modification. We can click the button Apply and see the change on the guide we are designing. So we can feel free to try as many changes as we need, trying to find the most adapt values for both parameters. Click Apply again, and then see if the final results we are obtaining is satisfactory enough to confirm and proceed to the next step. Moving forward, we can find the option for adding inspection windows into the surgical guide, which is an extremely useful reference to check if the guide is actually in a correct position and in contact with the teeth. Once again, it's up to the dentist to decide how many windows create and in which positions to place them according to the specific situation. It depends, of course, on what are the key points that we want to double check for the stability of our guide, and of course, the success of our restoration. As you can see, we have both square and rounded shape for the windows, in order to find the best fitting according to the position where we want to place them. Thickness and length of the squared windows and diameter and length for the rounded ones are also parameters that can be changed according to the specific needs. As always, we can regulate these settings thanks to the sliders in the box on the left. EXOPLAN is now processing the calculation for the creation of what we have just designed. And here we are in the design phase. As in every design phase of EXOCAD and EXOPLAN, here we can also freeform the shape of our guide by adding or removing material or by smoothing the surface of it. Always considering that it will never be possible to modify the internal part of the surgical guide, and of course it will never be possible to modify the sleeves. At the end of this design process, as it already happened at the end of EXOPLAN basic process, for the implant planning, we can find again the button to create the PDF report called Surgical Guide Protocol, where of course we will be able to find the information and the setting and the parameters that we have defined during the second part of the workflow. We are now at the end of the process and we are ready now to print our surgical guide.
Thanks a lot, Riccardo. Here is Filippo. Hello to everybody. And in the next 2 minutes, we will see together the printing phase of the surgical guide. I have imported the STL that we created with Explan in the 3D DLP software. And after set the resin to print the surgical guide, I started the printing phase. And here you are the result. After just 30 minutes, the surgical guides are ready. Now it's necessary to remove the pins and we are ready to test the surgical guides on the model. Thank you for your time, thank you for your attention, and before starts with the question and answer time, I would like just to remember you that we have a new YouTube channel called Shining 3D Dental, where you can find all the webinars that we did in the past and also some short video with little training related, for example, the update process or specific tools that we have inside the scan software. Stay tuned and pay attention to the next teaser.